These are the frequently asked questions for pre-calculus. For the test of sections 1-1 to 1-3, we're going to look at some problems from the day 2 review, which is the review right before we take the test. So the first one that somebody had asked about deals with linear regression. Here we have a table of employment statistics from 1954 to 2004 for men and women, and it says if the percentages continue to follow the linear models you found in exercise 15, what will the employment percentages for women and men be in the year 2009? So what we have to do is we need to do linear regression and check what the formula would be for that linear regression for both women and for men. And then since they're asking about 2009, we would take 2009 and subtract the original year of 1954, which I'm going to call my 0 year here. So you'll notice here that the pattern is 4s and 9s, 4s and 9s, 4s and 9s in that ones digit, which means it's going by 5 each time. So if we take 2009 and we subtract 1954, we're going to get 55 years. So we need to do the linear regression, and then we need to figure out what those percentages would be in the year 2009. I did already put these into the emulator, so they are good to go under Stats. Number 1, Edit. So the first one I wanted to do, I did put the females in L sub 2, is going to be the females. So Stats, arrow to the right once for Calculate, number 4. And I need to tell the calculator I want it to use list 1, which is my years since 1954. So second, number 1. And then I want it to use L sub 2, so second, L sub 2. And then rather than trying to go from screen to screen and find that linear regression, I'm just going to have my calculator store that for me in Y sub 1. So variables, Y variables, number 1, 1, and down to calculate, and there it is. So my linear regression for the females, y equals 0.567x plus 32.459, and my r value is 0.987, so it's a pretty good line of best fit. And if I hit y equals, no rounding, it put the entire equation in there, which is really, really great. So now what I want to do is go back in and do the male. So Stats, Calculate, and this is number 4, linear regression. But this time I had the male statistics in list 1 and list 3. List 1 again was the years, but I need list 3. So second 3, down to store, I'm going to go variables, y variables, number 1, but now I'm going to choose number 2. And that will store that in that y sub 2 when I hit Calculate. So y equals negative 0.244x plus 83.218 with an r value of negative 0.957 or so. So it's still a pretty good line of best fit. Now I have all of that in y equals. And here comes the part where I can go ahead and do something a little bit trickier so that I don't have to go back and write down those linear equations and figure out what happened 55 years ago, and that is I'm just going to reset the table. So second window, and I'm going to ask it 55 years from now, give me that table. You know, just jump to 55 and tell me what's going on. So second, table, and notice that the first one up there is 55 years later, so I would be able to write down what I see, which is the women would be approximately 63.649%, and the men approximately 69.818%. So this is one of those times when that table comes in handy to get the information that we need off of there. All right, and you're going to still need the calculator for a couple of things, so let me hit second quit and get out of there and see what else you had asked for. All right, this is solve the equation algebraically and confirm graphically. What we have to do in 37 when we have part of the equation that is not the square root and some that is we have to isolate the radical. So that means we need to get it by itself. So what I'm going to do is I'm going to leave the x plus 1 where it is, but I'm going to add 2 square roots of x plus 4 to both sides. And that will make this x plus 1 equals 2 square roots of x plus 4. Now, to get rid of my radical, I can go ahead and square both sides. Now, if you're thinking, I'd divide by 2 first before I squared both sides. I hope not, because that would be a big mess. You know, you'd have x over 2 plus 1/2. And again, you have to remember, this has to be written out twice because we are squaring the entire side, left side of this equation. And that means you have to write that out twice. So on the right-hand side, when we square it, 2 squared is 4, but the square root of x plus 4 is just going to give us x plus 4. So that works out really nice. Over here, we have x squared plus 2x plus 1, and we have 4x plus 16. Then we pull everything over to one side, so we would subtract 4x from both sides and subtract 16, and that would give us x squared minus 2x minus 15, which gives us x minus 5 and x plus 3 for our factors, because two numbers that multiply to negative 15 and add to negative 2 would be negative 5 and positive 3. And our zeros are going to be at 5 and negative 3. But I'm suspicious. Here's why I'm suspicious. Whenever we raise equations to an even power, we always have that possibility of an extraneous solution. And so what we want to do is see where do these two, the line x plus 1 and the root, the radical, 2 square roots of x plus 4, where do they intersect? And that's why it says we want to confirm this graphically. So I'm going to go into y equals and clear out that information that I had in before for the linear regression. And we now have an x plus 1 and 2 square roots of x plus 4. And because the two zeros that I'm looking at are negative 3 and 5, I'm just going to go ahead and do my zoom standard window. There is my line. There is my radical. And we can clearly see that negative 3 is not a 0. And if we do second trace, number 5 intersection, bing, bang, boom, there is where Blinky tells us that intersection is at x equals 5. So we know that the negative 3 is out. And 5 is the correct equation, the correct solution for that equation. Number 18 is going to be very similar to what we just did in the last one. We have the square root of x equals, and we would go ahead and subtract an x from both sides because, again, we need to isolate that radical. And it doesn't matter whether or not you write this as negative x plus 1 or 1 minus x. Either way, we have to square both sides to get rid of that radical. So this would give us negative x plus 1 times negative x plus 1, which is x squared minus an x minus 2x, and 1 times 1 is going to give us 1. So we're going to go ahead and move that x over, so x squared minus 3x plus 1, and we try to think, you know, is this going to be factorable, so this will be a little bit easier to do. Obviously, there are not two numbers that multiply to 1 and add to negative 3. So we're going to complete the square. We're going to move the 1 out of the way by subtracting it. And then we take b over 2 and square it. So that's going to be 9/4. And what I do to one side, I have to do to the other. So I've added that 9/4. Negative 1 is a negative 4/4, so negative 4/4 plus 9/4 is 5/4. And on this side, we will get x, and then we think, well, what did we square to get the 9/4? That was a negative 3/2. next step is to take the square root, both the positive and negative square root of both sides of this equation. So this will be positive and negative square root of 5, because that's not simplifiable, over 2 equals x minus 3 halves, and then we add 3 halves to both sides. And we have two solutions. But again, we raised both sides of this equation to a power way back here at the beginning when we had that square root of x piece. So if we do this many, many, many times, we will get an extraneous solution. So let's go ahead and punch this into the calculator and see what it's going to tell us the solutions are. And let's see, we have the square root of x plus x. And then just a little 1 on the other side of that equation. There's our square root. And there is our 1. So let's see what that is. Second trace, number 5, enter, enter, enter. Let's let Blinky tell us that. Blinky says about 0.382. So approximately 0.382. And we check to see, okay, well, how are we going to get that answer? Would we use 3 halves plus the square root of 5 over 2? And we punch that in, and that's not 0.382. So our exact answer is 3 halves minus the square root of 5 over 2, because that's the only one that works. Now, at this point, you'll notice that I did not punch that into the calculator for you, because I know you are more than capable of doing that. And again, you'd punch in 3 halves plus the square root of 5 over 2. That does not come out to 0.382, and then 3 halves minus the square root of 5 over 2. And that one does come out to what we needed. And then I think I can go right down, yep, to 39. So 39 says solve the equation graphically by converting it to an equivalent equation with a 0 on the right-hand side, and then finding the x-intercepts. So really what they want us to do is just move everything over to one side. I'm going to go ahead and move this over to the other side by subtracting that square root, negative square root of x plus 4. So 2x minus 5 minus the square root of x plus 4 equals 0. And it's back to the calculator. We go. Y equals, clear, clear. And we want 2x minus 5 minus the square root of x plus 4. There we go. And let's see if we can see that in a negative 10 to 10 window. There's our 2x minus 5, which was linear. And what we're looking for here is that point where this is going to cross the x-axis. Now, we look at that and think, you know, it's linear. Well, what we need to do is figure out where is that intersection with the x-axis, right there. What is that all about? So second trace, number 2. And I'm going to get Blinky up here. It says left bound. I want Blinky just below that intersection and press enter. Put Blinky above the intersection with the right arrow. Enter. Enter through guess. And x is approximately 3.906. With some rounding. Now, can we get that algebraically? And the answer to that is, of course, yes, sure we can. So if we go back, and take a look at this. They didn't ask us to, but it's just a good way to check. It would be to take 2x minus 5 and square it, and square the radical on the other side. And so 2x minus 5 times 2x minus 5 will equal x plus 4. We'll get 4x squared minus 10x is minus 20x plus 25 equals x plus 4. And 4x squared minus 21x, and then if we subtract the 4 from both sides, plus 21 equals 0. And then it's a matter at that point of whether or not you want to use completing the square or quadratic formula. Give myself a little space here, because the first thing I'm going to need to do is get rid of that 4. Remember that to complete the square, you have to have a 1 for that leading coefficient. Oh boy, the smartboard is having some issues. Come on down. All right, so I'm going to divide everything by 4. And get x squared minus 21 fourths x plus 21 fourths equals 0. So x squared minus 21 fourths x equals a negative 21 fourths, because what we have to do now is our b over 2 squared process to fill in that gap right there. So we're going to need negative 21 fourths, and we need to divide that by 2. But since it's a fraction, a lot easier to just go ahead and multiply by 1/2. So a negative 21 eighths. And then we need to square that negative 21 eighths. And see what we get. So 21 squared is 441 64ths. So let's go ahead and add 441 64ths to both sides. And then we would go ahead and write our perfect square trinomial as a binomial squared. And we just think for a second, what did we square to get? Negative 21 fourths. Well, that was a negative 21 eighths. And on the other side, we're going to need our nice little negative 21 fourths plus 441 64ths. And that is 105 64ths. So at this point, we would take the square root of both sides. And x minus 21 eighths would equal the square root of 105 plus or minus the square root of 105 over 8. And then we would go ahead and add the 21 eighths to both sides. And then we would have used our graphing calculator, because that's what they're asking us to do right now, to figure out what the real 0 was, and then come back and figure out which one of these two is actually going to produce that number. And it is the one with the addition that's taking place here. So x equals 21 eighths plus the square root of 105 over 8.